Hey everyone, welcome back. Today we are diving into the world of databases, specifically relational databases, as part of a SQL bootcamp. Relational databases are the workhorses behind many of the applications we use every day, and understanding them is critical to unlock the power of SQL. So, let's jump right in. From our previous video, we understand that SQL is a standard language used to interact with a relational database management system. But what is a relational database? How do relational databases compare with their earlier technologies? How is data stored in a relational database? What are the advantages and disadvantages of a relational model? By the end of this video, you should be able to answer all of these questions. Let's begin with the first one. What is a relational database? Imagine a library. Books are like data, and you need a way to organize them for easy access. A relational database is like a super organized library with sections for different categories such as fiction, non-fiction, etc. Similarly, database management systems organize and structure data to be saved and retrieved by users and application programs. How do relational databases compare with their earlier technologies? Before databases, data such as payroll and accounting were stored in individual files. File management systems, like folders in Windows, track file names and locations. These systems had no data model and limited information about file contents. Limitations of file based systems led to databases. Databases move data structure and definition out of individual files. This allowed a central management system called DBMS, Database Management Systems, to handle data and changes. DBMS uses the operating system's file system to store the actual database structures. Users interact with the DBMS, which handles the physical storage details. With the increase in data complexity and the needs, different types of databases emerged. One of them is Hierarchical DBMS. To understand this, imagine a family tree. It's like a hierarchical database. It organizes data in a parent child relationship, forming a tree like structure. Each record is like a person in the family tree. It has one parent record, their ancestor, and can have multiple child records, their descendants. You navigate through the hierarchy to find specific data, like how you follow branches in the family tree to find a particular person. Hierarchical databases offer a clear tree like structure for data organization. However, their simple structure becomes a disadvantage when the data has a more complex structure. A new network data model was developed to handle the complex structures. It offers a way to organize and manage data focusing on complex relationships. Unlike the hierarchical model's parent child structure, the network model allows for a more interconnected and flexible approach to handle many to many relationships. Though the network data model offers a powerful approach to modeling complex data relationships, its complexity and potential for data redundancy make it less common than relational models, which are standardized and scalable. What is the relational data model? It is the foundation of relational databases and provides a structured and organized way to store and manage data. It's like a well designed library with clear sections and a catalog system for easy access. Let's see how the data is stored in a relational database. Data is stored in two-dimensional tables. similar to spreadsheets. Each table represents a specific category of information. Example, customers, products, orders, etc. Tables are made up of rows and columns. The rows are nothing but records, and columns are known as attributes in the database terms. Each row represents a single instance of data. Example, a specific customer. And each column represents a specific characteristic of that data. Example, customer name, address, etc. A table can have any number of rows and no particular order, while the columns are arranged from left to right following a specific order. Because the rows of a relational table are unordered, you cannot select a specific row by its position in the table. There is no first row, last row, or 13th row. So, how can you fetch a particular row? That is where the primary key, a crucial concept, comes into play. This is a unique identifier for each row in a table, ensures no duplicate entries exist. However, tables are not isolated entities. Relationships between tables are established using foreign keys. A foreign key is a column in one table that references the primary key of another table, allowing you to connect related data across tables. Thus, a relational DBMS can represent parent child relationships, but these relationships are visible only through the data values contained in the database tables. Together, a primary key and a foreign key create a parent child relationship between the tables that contain them, similar to the parent child relationship in a hierarchical database. Also, another crucial concept to discuss is schema, which is nothing but a collection of tables. It outlines the database structure by defining how data is organized and their associated relations. Let's see the advantages and disadvantages of a relational database. Talking about advantages, data integrity. Relational databases enforce data integrity through techniques of primary keys and foreign keys. This ensures data accuracy and consistency across tables. Standardization. Structured query language (SQL) is the standard language for interacting with relational databases. This allows you to port your skills and queries across relational database systems. Flexibility. The relational model can handle various data structures and relationships, adapting to various data management needs, from simple customer information to complex financial transactions. Scalability. Relational databases efficiently manage large and growing data sets and can effectively scale to accommodate increasing data. Data sharing and collaboration. A well defined schema facilitates data sharing and collaboration. Everyone working with the database clearly understands how data is organized and can access it efficiently. Talking about the disadvantages, complexity for simple data. For a very basic data structure, a relational database might be overkill compared to more straightforward solutions like flat files. Performance considerations. Complex queries involving multiple joins between tables can impact performance. Careful optimization might be required for efficient data retrieval in these cases. Data modeling challenges. Designing an efficient and flexible data model can be challenging, especially for complex data relationships. Limited support for non relational data. Relational databases are primarily designed for structured data. They might not be the best choice for storing and managing unstructured data, such as social media posts or sensor data. In summary, Relational databases offer a robust and standardized approach to data management, making them the dominant choice for various applications. However, alternative solutions might be more suitable for simple or highly unstructured data structures. I hope you get the overview of relational databases. If you have any questions or need clarification, please comment below. See you in the next one.